Okay, I had a request to do some exercises from 9.5. These are proof type exercises. I realize it's hard to write these out. So let's go for it. 9.5.13 says prove 4z is a subgroup of z. Now 4z is the same thing as the cyclic group generated by 4. As you can see here, it's all the multiples of 4. And we want to show this is a subgroup of z. So I'm going to go back and use a proposition from 9.4.12, which says, let H be a subset of a group G, then H is a subgroup of G, if and only if H is non-empty, and for any two elements in this subset H, then GH inverse is also in H. All right, so two things you have to prove. If you have a subset of a group, you have to show the subset's non-empty, and that any two elements, G and H, then GH inverse is in H. Right? So here's my argument, which is more or less elegant. So we will use proposition 9.4.12 to prove that 4z is a subgroup of z. Okay. First, we need to show that 4z is non-empty. Now, I didn't write that 4z is a subset of z. You just can kind of assume that. It's pretty clear. But first, I need to show that 4z is non-empty, so 0 is in 4z, so 4z is non-empty. And then I have to show the second part, which is the harder part, that whenever G and H are in the subset, then GH inverse is in the subset. So let me take two elements of my subset, which is 4z. In this case, my H is substituting for 4z, and my G is substituting for z. Okay, so I'm going to do my proof in terms of 4z and z, but you should understand that 4z takes the place of H, and z takes the place of G. Right? So let me take two elements of the subset. Now, by the definition of 4z, n is 4 times an integer, and m is 4 times an integer. So you can write it this way. N is 4k, m is 4l, where k and l are in z, and that's by the definition of 4z. Right? Now, then what do I have to do? I have to take the first element plus the composed with the inverse of the second element. Now, my group operation is plus. So instead of writing times or compose, I have to use the group operation. In this case, G is going to be my n, and H inverse is the inverse of my m, but since I'm using addition, the inverse is minus m, and the group operation is plus, so instead of writing times, I write plus. So this n plus minus m, this substitutes for GH inverse. Right? So let me continue with this. If I do the substitution here, where n equals 4k and m equals 4l, I just plug those in. I factor out the 4 using distributive law. And what does that tell me? It tells me I have that n plus minus m is 4 times an integer. Okay, so n plus minus m is 4 times the integer. So it's in 4z. That's what 4z means. It's all the numbers that are 4 times an integer. Right? So what have I shown? 4z is my subset. So I've shown that if you take any two elements of the subset, then the first plus the inverse of the second is also in the subset. So that completes the proof that 4z is a subgroup of z. And that's really all you have to do. And you can even do it within one page.